You want to handle this?
Yes.
Uniform rigid body of mass m. Just let's go to the strategy now. Let's not go on solving the problem. Let's look at the strategy. Uniform rigid body of mass m and round section of radius r rolls down a slope of inclined theta and horizontal. The radius of gyration of the body about its central axis of symmetry is k. Okay. Derive the suitable expression for angular velocity and velocity of the mass center after it covers a distance x. I think we can handle this now. Yesterday we have done similar problem.
Yes, sir. Yes.
So now only thing is you have to assume it starts with 0. It starts with 0, then it rolls down an incline. So mg sin theta is acting in this direction, right? So mg sin theta, you will calculate the torque, right? So the torque is calculated. So the torque will not change. Torque is constant. So therefore alpha is constant.
Yes, it is.
Right? And therefore omega keeps on increasing. Okay, at the same and it is rolling without slipping. So once you know omega, then you know Vc. So Vc will be equal to omega r. Okay, and therefore Vc is also increasing as omega is increasing.
Yes,
and then they are told it travels a horizontal distance x. So it travels a horizontal distance x here. Okay, so x is equal to this horizontal distance is x. And we will now get Vc in terms of omega, and you can now the translational acceleration at will be equal to alpha r. Okay, alpha r. So v is equal to x is equal to v square minus u square. U is 0 by 2a, and a is alpha into r. So put those things here. So you will get here. Only thing is now the radius of gyration is given k. Now you should know how to handle this. I is equal to m k square. I is equal to m k square. Okay, so you will get this one from this. You know how to handle it. Okay, friends, and angular acceleration, and this is also automatically calculated.
Yes, sir. Sir, the first part, sir, using the energy to be easier.
Energy also it is easy. Correct. I was coming to that point. One is, we have solved it like that. Yes, another thing is now use the energy principle and do it. So from this x here, so this height will be what if this is theta. So this will be x tan theta. Now if this is theta, x sin theta. Okay, so here it comes down to this. So the potential energy is now converted into kinetic energy. What is the potential energy here? Potential energy is mg into x sin theta. Okay, now that is equal to half I omega square plus half m this.
It is
Translated and rotation. And v you write it in terms of omega. And then if you write v in terms of omega, then m anyway you will write it in terms of k. V square, k square, r square equation you get.
Only in terms of I omega square.
Got it now? So both the methods you can.
Okay.
You can use Newtonian as well as you can use this. Earlier in translation also we have that. Only thing is in translation the body was sliding here.
Yes,
so here it is rolling.
Yes,
okay, friends. Hello.
Yes, yes.
So we'll just straight away look into the answer. This is quite simple. We know the strategy how it works, right? Same thing. So VC is equal to omega, AC is equal to
yes.
See, because all the problems I'm telling you students, as soon as you read the problem, what are all the abstractions visually you can get, simply write it.
Yes, sir.
Simply write it. Okay. And initially K1 is equal to 0. And finally K will be equal to half EC square plus half omega. And IC is equal to FA. All this data is given. This is by inspection, you will write this. Okay? Right? So just keep on writing this. You got K2. So mgx sin theta. We wrote this. So then finally K2 minus K1 will be squared. Let's VC is equal to squared. Looks very simple, correct? And it is in fact simple. Okay, okay, friends. See, now we were all solving, in kinematics. A body is sliding from this, calculate its velocity. Now, see, that is a trivial thing here. It's a part and parcel of a bigger thing.
Yes, sir.
Shall I proceed, students?
Yes, sir. Yes, sir. Yes, sir.
So now, one basic question. See here. This is what I was discussing at the beginning of the class. See, this is a very good illustration. A pendulum is moving here. So, are there different kinetic energies? That is, rotational kinetic energy. This actually, if you take the particle analysis, both are same. And what is rotational?
Yes.
It is summation of all this.
Yes, sir.
Okay, so that aspect is brought out here. Okay, because omega we will get related. So kinetic energy half mv square is equal to this. See, for a bob, you can either consider it like this or like this.
Yes, sir.
See, we have derived the time period of the bob, if you remember,
Yes.
by writing both the equations, treating it as this as translative motion or this.
Yes, sir.
I hope you remember this.
Yes, sir.
Okay, already we have used it.
Yes, sir.
So now the above integral summation is conveniently regrouped to kinetic energy so by the virtue of motion. So kinetic energy of system is translation kinetic energy about center of mass, rotational kinetic energy about center of mass. See, if it is not rotating about the center of mass, that is, if it is pivoted here,
Yes, sir.
then what?
Yes,
If it is pivoted, then it's only rotational.
Yes, sir.
Understand? So therefore, this definitely rotational about the center of mass and translation energy of the center of mass.
Yes,
Okay, that problem is solved now. In the starting, we had the question asked. Okay, anyway, I'll show you a illustration. Kushi ro, ekdam silent aguttan huduga. ನೀವು ದಿನ ಇದ್ದಂಗೆ ಇರ್ಬೇಕು ಒಂದೊಂದು ದಿವಸ ಒಂದೊಂದು ಇದು ನಮ್ಮ ಪ್ರಾಬ್ಲಮ್ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. This one you do. What is the total kinetic energy of the above system? How is it up proportionate as translation and rotation? Up proportionate, how will you say? If supposing you want to say, see, now you can do it by both methods.
Yes, sir.
Okay, directly you can take it as IP here, and you can calculate the kinetic energy.
Yes, sir.
But remember, there are 2 points here. Okay, and this is kept here, but this will not be the center of mass. I suppose you know.
Yes, sir.
The center of mass will be somewhere here. Be careful.
Yes.
Right? So, one minute. Appropriate means if you take this and calculate the total kinetic energy with respect to this point, you will get I naught into half I naught into omega naught square. Now you can split that into translation and kinetic energy in this case.
Yes.
Now you will get that idea. Now what one doubt man?
Sir, that the second rod, sir, it is like it is fixed to the mass.
Oh, hello. Second rod is one rod is there.
Okay, sir.
Ida one rod is there. Not ile light rods. Sorry, there are 2 rods, but it is fixed. They are not told it is hinged here. It is hinged only here. See, this is the symbol of hinge. This is fixed. These 2 are fixed here. Okay, solve this. I think you can solve this. Aram se, cautiously solve. So your question will be answered here.
They have given velocity from that second. V.
They are going to be there. So they have given V there. They are given this V. And therefore, this V has to be what?
V by 2.
V by 2. That's it. So the kinetic energy of this will be half m V by 2 whole square.
Yes.
Plus the kinetic energy of this will be half m V square.
Sir. Sir, rotation. Rotation part.
ಅದೇ ಹೇಳ್ತಿರೋದು this will be the total kinetic energy.
Initial.
What initially?
Yes,
See,
yes.
at some point, see, this will be maintained. This
Sir,
V is in general.
Okay.
This V is in general.
Yes, sir. Yes, sir.
In general, and this relation is always maintained.
Yes, sir.
V will change.
Yes, sir. We will.
So what is this? This will be the total kinetic energy. See, this is moving, man.
Yes,
Its
yes,
kinetic
yes.
energy is this. This
Yes.
kinetic energy is this.
Yes.
So here half m will come out.
V square.
Half m V square will also come out. So what will be there here? 1 by 4 will be here. Plus here 1. So this will be 5m V square
By
by 8. This will be the total kinetic energy at some point.
Yes.
If you want to convert it into, if you see that it is rotating, then V is equal to what?
Omega by omega 2.
V is equal to omega into 2L.
Yes.
Okay, omega into 2L.
Yes, sir.
V is equal to. So here 5m by 8 into
Omega square.
Omega square
4
into 4L square. So 4 into 4 2.
Yes.
Okay, so you get a 5 by 2m
Yes, sir.
omega square L square. That will be the total kinetic energy.
Yes, sir.
Okay, did you all get the same answer or something else?
Same, sir.
Same, no, see, that's it. See, by the virtue of its motion, you only look at it, you will get it.
Yes, sir.
And if you look at it from this point of view, then you say, okay, it is rotating about this point, then you convert it into omega and write the answer. Other is this.
Yes, sir.
This is first part. Now that you have got this total kinetic energy, now you see, this is the total kinetic energy. Now you write this as translation kinetic energy plus rotation kinetic energy. Now your job is that.
Yes, sir.
Now do that. So for that, what you will do, Mr. Arun, you calculate the center of mass.
Center of mass.
So the center of mass of this will be here.
Middle.
Okay, and this will be L by 2.
Yes, sir.
Okay, now you consider this, both the masses are here, 2m is here. At what distance from here? L plus L by 2.
Okay. Yes. Yes, sir. Yes.
Mm. So now when this is
So separately we need to write the equation.
write it, separate and write.
Separate.
Separate and write. Everybody, Aram, take
Yes.
some time.
Sir, someone is waiting. Sir.
Thank you. Someone at home is waiting on the left. ಕಣಗಿಲ್ಲ ಕಣಗಿಲ್ಲ
ಬೋರ್ಡ್ ವಿಡಿಯೋ
ಆಯ್ತಾ ಆ ವಿಡಿಯೋದಲ್ಲಿ ನೋಡಿದ್ದೀನಿ ಅದಕ್ಕೆ ಯೂಶಲಿ ಹುಡುಗರು ಯಾವ್ದು ಹುಡುಗಿ ಬಂತಂದ್ರೆ ನಾನು ಬೇಕು ಹೆಸರು ತೊಗೊಳಂಗಿಲ್ಲ ಭಾರಿ ಪ್ರತಿ ಜನ ಹುಡುಗ ಸೋಷಲ್ ವರ್ಕ್. Okay, can you separate it?
Yes, sir.
See, K of the transitional category is what? Half mass of the system into VCM square.
Yes, sir. Yes, sir. Yes, sir.
And K of rotation will be what?
Half LC.
Half
LC omega square.
IC
Omega square.
into omega square.
Yes, sir.
That is the
Moment of
inertia about the center.
Yes, sir.
Correct?
Ah,
Very
right.
good, very good. So here our m will be what? Half. Our m will be 2m.
Yes, sir.
Okay?
And velocity center of mass will be 3d by 4.
Yes. Or if you take omega there, if you take omega, then omega is common.
Yes, sir.
Omega is common. So this will be 3l by 2
3 guys.
whole square. So if you take omega common, you will get it like this.
Yes, sir.
Okay? And this will be half. Okay? Into what will be IC here?
Sir, ml square by 4. Sir.
ml square by 4.
Sir, like ml square by 2, sir. Like,
This will be L by 2, L by 2.
yeah, yes, sir. So it will be ml square by 4 plus ml square by
ml
4.
square by 2.
So it will be 2 ml square by 2, sir.
ml square by 2 only.
Yes, sir.
Okay? Into omega square.
Yes, sir.
How ml square by 2?
Okay? From here to here it is ml square by 4. From here to here it is ml square by 4. Add them. Oh!
Sir, but total that distance will be 3L by 2, sir. So moment about that one.
IC man, only IC. This will be the new IC.
Yes, sir.
This will be the center of mass.
Yes, sir.
Okay, so translational kinetic energy is this and rotational is this. So here half is there, so this two will go and you get here m into 9
V square by 4.
l square by 4
Yes, sir.
omega square. Correct now?
Yes,
M
sir, yes,
into
sir.
9 l square omega square
Yes,
and
sir.
this will be what? So
ml
this will
square
be
omega square by
m l square
omega square
omega square by 4. So you separate out the two things.
Yes, sir.
Now you got the idea?
Ah, sir. Ah, sir. Yes, sir. If you add again, you get this by x square.
Now, if you add again, you should get the same.
Yes, sir.
You get tested. Arey wow, so nice. I'm so happy to see Dhiman solving very happily. Both Dhiman and Arun here. They are very nicely, happily solving and very confidently they are telling the answers. Friends, did you get it? All of you?
Yes, sir. Yes, sir. Yes.
Understood? So this is the basic formula. Just have to write these things.
Yes, sir. Yes,
Okay,
sir.
thanks. See, at this space, how many numericals we can solve? Understand? See, if you are understanding, you know, if you have the knowledge, then keep on applying the knowledge. Alright, we should see the answer also, no? Let's see. Confident. So here we got
Correct.
5 ml square omega square. We got the same answer here?
Yes.
Yes. See this also we wrote the same thing. We didn't do any garbad here. Right.
Yes,
Then
sir.
omega
Yes.
is here. Okay, we wrote it directly. This is m. Here we got m system into VCM square. Rotation is half into ICM into omega.
Yes.
Okay, kinetic energy of rotation. Right? So we got the same answer. And adding the two, again we are going to get the same answer. In the above illustration, the system is in pure rotation about the point, and the total kinetic energy also seen as rotational kinetic energy. Half I IP square is ml square plus m into 2l square 5 ml square. So K is equal to this. So you see, now if you consider at the point
sir.
P, then it is pure rotation.
Yes, sir. Yes, sir.
Now you got the idea?
Yes, sir.
Huh? It is pure rotation. So if you don't want to consider that point P, then you take that separately, VCM and this, and you get it.
Okay.
Or if you take individual masses, simply calculate the V square.
Yes.
I hope everybody got this.
Very good, same.
See, now in different perspectives, I have shown you the answer. So no confusion should be there in your mind.
Yes.